Hi, welcome everyone. In this video, we will learn how to edit Blink LED app in Arduino App Lab and get familiar with the Arduino App Lab files. After opening the App Lab, select Blink LED app. Click on the two squares in the top right corner to copy the app. Change the name or leave it as copy of Blink LED. The App Lab will create the copy of Blink LED app. For now, the only difference between the Blink LED and the copy of Blink LED apps is the name. And if you open the copy of Blink LED, you will find the app YAML has the name as copy of Blink LED. This is created by the App Lab, but the description is the same as in Blink LED example. This will not affect the function of the copy of Blink LED app. I will edit this at the end of the video. I edited the sketch.ino using the App Lab to use external LED connected to pin 7 instead of the built-in LED, and print the LED state in a serial monitor. But main.py stays the same as Blink LED example. In the next few segments, I will give a summary about the App Lab folder and files. You will notice there are three folders in the left sidebar: Bricks, Sketch Library, and Files. Bricks and Sketch Library are not used so far. Under File, there are three folders: Assets, Python, Sketch, and two files: README and app.yaml. Assets folder has the supported documents. Python folder has main.py file. The Sketch folder has sketch.ino and sketch.yaml files. Now we have a summary of the app folder and file. Let us start by quick explanation of the UNO Q and edit the app by changing the built-in LED to LED connected to pin 7 and print the status of the LED in the serial monitor. The UNO Q has a microprocessor running a full Debian Linux operating system, where Python application main.py run. It also has a microcontroller running Arduino sketch.ino on top of Zephyr real-time operating system, a bridge needed to communicate between the microprocessor and the microcontroller. For bridge communication, you will notice the first command line in the sketch.ino is include Arduino _router bridge.h, and in void setup Bridge.begin and Bridge.provide. And the main.py has from Arduino App util import star. This means it will import all Arduino App utility, which include the router bridge, and also it has bridge call. The loop function in main.py toggles the LED state between true and false every second. The bridge call will send the LED state to Bridge.provide in sketch.ino. The Bridge.provide and sketch.ino will send the set LED state function, the LED state, to turn LED on and off, and print the LED state in the serial monitor. Before running the app, make sure you connected the LED to the Arduino UNO Q pin 7 with a 220 ohm resistor, and make sure it is connected to the UNO ground. Let us run the app by clicking the green button in the top right corner. A green bar has a copy of blink LED now running will display in the bottom terminal. Once select Serial Monitor in Terminal, you will see the LED status. When select by Sun, you will see App Started, and you will see the LED blinking. Now the copy blink LED app is running correctly. We will edit the description in app.yaml. We cannot edit the app.yaml in the App Lab. I will edit it using Computer Terminal or VS Code. To use Computer Terminal in Mac, click in the arrow in the left side of the IP address in the bottom of the screen in the App Lab. The terminal will open and ask for Arduino UNO password. After connecting to the Arduino board, follow the steps in the screen and open copy of blink LED folder, then type nano app.yaml. This will open the terminal editor. Edit the file, then save it. Close the App Lab, then open it again. You will see the new edited app.yaml. You can edit the readme.md file the same way or using the App Lab. If you want to use VS Code, first we have to open VS Code application, then click in Open Remote Window in the bottom left side, then select Connect to Host. I already have UNO Q1 set up ready. To use it, I click on it. VS Code will ask for Arduino UNO Q password. Then when I click enter, you will see this screen. Click open folder, then OK. Now you will have access to the board directory and can open any folder or file to edit. If you don't have the board added yet, after opening the remote window, select Connect to Host and added new SSH host. In this new screen, enter Arduino at the same address you will see in your App Lab in the bottom left corner. Click enter. Check if the configuration has the same format in the screen. The host name should be the same as your board name that appear when you log in to the App Lab. Close VS Code configuration. Now you will see your board name when you select Connect to Host, and you can access the Arduino UNO Q board as I explained before in my board UNO Q1. Now in VS Code you only have access to the apps you created. To have access to all the file and the example in the board, you have to install Arduino App Studio. To install Arduino App Studio, after you connect to the Arduino board using SSH, you click Shift Command X. Search for Arduino App Studio, then click Install. You will have a new icon for Arduino App Lab Studio in the left side bar. Click on the icon Arduino App Studio. You will have access to all example bricks and models. From the next video, we will start building our project.